So, welcome back. Now, since last you saw this Philitina number 2 from Philips, I have managed to extract it. I can tell you, if you're ever trying to approach a similar endeavor, that these knobs do in fact have a small set screw. However, Philips has sealed the hole with beeswax or some sort of paraffin wax or something. So first you need to basically dig your way through that with a suitably sized screwdriver. I used my largest Pico finish. That's a 3 millimeter wide blade. The screw on the other side takes a 2.5 mil blade. So basically you dig it out until you catch the screw. It's fairly deep inside and it's threaded only into the shaft here. So you need to dig out the wax, back out the screw, and then it only disengages from the shaft at the very, very end. So you need to somehow make it almost drop out and apply a little bit of pressure. It took me a while to figure out that one. It's the same on the big boy dial over here. This one here. The reason, which is a happy coincidence, that this thing was spinning is that the glue has let go. So that will be easy to sort out. Missing that disc from there, but we'll manage. And I have managed to get it out. Philips, kindly enough, used 3 of these bastards, 2 which hold the case in, 1 there, and 1 over there in the bottom right corner or there. And also there's 1 holding a grounding tab, this thing here, on. That thing there flopping about in the breeze. Then you also need to desolder the speaker wires, which I have done here. So that's where you can get it out. So now it's terribly filthy, we're going to deal with that, but I was thinking that might as well have a look at some of the components. And as we all know, this one is going to be the main offender. It's a 50 and a 100 microfarad 250 volt cap inside. I haven't powered this on for over a year, so I'm fairly confident that I can, just go at it without discharging it. But, I'm risking my own instruments, basically. So let's see if we can get all of this nonsense in frame here. I also see one of the... we'll get to that. But yeah, let's turn this one on. And I think these 3 outside lugs here are the outer shield of the cap. We could, of course, test that with our friendly multimeter. Just give me a second to prepare. We're going to fetch the probes. We're using the Fluke 45 today because it's a nice robust meter and has a very nice and bright VFD. So yeah, let's see. Well, let's put it into diode mode so we get a nice beep. So these 2 should be connected, and these 2 should be connected, and these 2 should be connected, and those are all connected to case. And you can't see shit what I'm doing. But yeah. So that's the ground side of the capacitor. So we're going to take our little ESD probes. I think we have a blob of solder there that we can hook to. And then we're going to give that side a go. And the peak just turned off, of course. Yeah. Okay. So that one is leaky, according to the peak. And we're going to plop that onto the next knob. And that one is down to 83 microfarads. So my guess is that the 83 one, can't remember if they do go up in capacitance or down. We could, of course, check that once we desolder it. But let's start with that. I'm not going to bother with making this look, original or anything. It's a very compact radio. It's not like you open it up and this one is in the back. I'm just going to replace it with two nice filter capacitors instead, modern ones. I think, and how it's oriented, I think I could actually use normal vertical ones. So now this is going to prove to be a bit hard because we need to, like this, as you have noticed, this tube radio has a PCB, which is a bit unusual. So we have to be a bit careful when using a desoldering gun on this thing, because I'm not too keen on ripping 1960s vintage pads. So we're going to apply a bit of new solder just to get the iron something to bite on. And then we're going to, it also like helps you with getting a good grip on it. Is that actually a blob of solder? Yeah. Would you look at that? But yeah, that's just to remove the bulk. I'm probably going to fiddle with this bit, so I don't think you want to watch me struggle for half an eternity trying to get all of this out. So yeah, I'm just going to fiddle with this. Oh, lovely. Lovely. We could get that lead up. Yeah, because as you see, they've bent the leads over. And, since I'm not 100% committed to just recapping this with modern caps, I'm going to try to, wiggle this one out of here. So yeah, I'm going to do that off camera, so that I don't have a camera in between me and the thing I'm working on. And I'll get back to you once I get it out. So, we're back. A bit of a struggle. This PCB is quite fragile. However, it's very thick copper that they've used. So, you don't have to baby it, but you will most definitely rip traces if you're not careful. But it gives you a bit of warning. So now we can see that there's need a pointing device. One moment, please. There you go. So now we can tell that there are, in fact, symbols on the leads here. A square and a triangle. And on these old caps you can read, on multi-caps you can read it out of here, that the square is the 100 microfarad and the triangle is the 50 microfarad. And they're both rated at 250 volts and a temperature of 70 degrees, which is, a bit low. So, first of all, let's try it with the I think it was the triangle that was bad. So let's see if it's like really bad. Let's put this on ohms. There's still some sort of cap there. Now I don't have a capacitor analyzer per se. Oh, well, I technically have something like that in my fluke, but let's try it again. So we'll connect the peak. And now it's actually saying 37 microfarad. So it might be that we actually had something leaky in there. Let's see the new one. And this is 72. So yeah, they're both out of spec, reading low. I don't really care what the ESR is. This thing is going, most definitely. It's old, it's ancient. And I think I have better caps in store anyhow. The only thing I need to check is that this thing actually wasn't, conducting the ground plane through, which is, when you look at how they've set it up, these three should actually be connected. I guess we can test that. And yeah. Okay, so those two are still connected. but that one is not. And as you can see on this one, you know, all those legs are in fact connected. So yeah, we need to do a bit of a jumper over there to jumper all these bad boys together, and then we'll just plonk in a new pairs of capacitors. So let me see if I can find someone. So, welcome back. I've been going through this thing component by component, like a certain Portuguese YouTuber tends to do. And most of the components are just fine. I found a couple of electrolytics that needs to be changed, and one or two resistors that might need a refresh. But otherwise, like, almost all components measure out just fine, which is maybe a testament to Philips. One thing that a bit scares me are these phono input capacitors, because they have spec'd, they are 4.7 nanofarads, these big boys over here, and they are rated at a whopping 1.3 kilovolts, which is a bit excessive considering that the radio is, you know, I don't think there's a voltage over 200 volts in this thing. It's rather low voltage for what it is. So I thought, let's put them through the Megger. I don't have one of those, you know, high voltage testers that, you know, you've seen some people build, but I do have a Megger. So this thing is an insulation tester, and it will test, you know, insulation up to 1000 volts. So let's see what it says. And yeah, it's 0.32 megohms. So let me do a quick calculation. It's only at 500 volts, but we'll do a quick calculation and see how much leakage that actually is. So we're back. Yeah, that's basically shite. I checked and did some calculations, and that's like a milliohm, about 1.5 milliohms, which is definitely bad. Let's check its body to see what it says. I also find an interesting piece of information that capacitors like these are supposed to handle it like it should be in like off the scale, like megaohms, several hundred megaohms. Yeah, and that one is equally bad. Let's get I have a 600 volt cap, a nice orange drop. It's a this one is a something or other, 47 nanofarad. This here bad boy, and it's rated at 600 volts. So just for shits and giggles, let's see what kind of values we get on a known good cap, or at least I presume it's good. Now with these long leads, we'll like, it's not going to kill you, but it could hurt a bit. Let's test it at 500 volts. And you see, yeah, off the bloody chart. So, yeah, we are definitely going to need some new caps, and one that's a bit more closer in specs. Let me see what we can rustle up in the... I do have... These ones would probably work, but I do have to order parts anyhow, so let's do it. This one is 0.01 microfarads at 630 volts. So let's see what that one says at 500 volts. it's also off the bloody chart. And you can see this one actually removes the charge after it's done. So it shorts out the capacitor through a burden resistor so you don't electrocute yourself. So those are going to get replaced with, like that one was approximately twice the size of what was needed. So we're going to replace those with some nice Illinois caps because they don't really need, I think the reason, like this is a bit speculation on my part, but these aren't really here for anything else but your safety. This has an isolation transformer. The way they've built it is that there's almost no exposed metal anywhere. Everything is covered in plastic. And when you see that, you should start worry a bit if they've isolated it. And since they are doing the exact same thing here, where they have for the phono input, which I think is actually stereo, yeah, because you have ground, they have put in these DC blocking capacitors, probably to keep you safe. So I think the 1.3 kilovolt rating on these are actually there because they didn't really trust capacitors back in the day. So I think it would be probably even worse if we ran it up to 1,000 volts, that the meter is most definitely capable of. But since they're in circuit, I'm not going to bother. So I think that might be it. That might be the reason for it, at least, why they went with those. But 630 volts is going to be just fine. They are, modern film capacitors. It's no biggie, so, as they say. But yeah, well, I'm going to order some parts now, and in the meantime, also going to try and clean it off a bit. I think we're going to have a nice radio. But, nothing really majorly wrong with this one, except the main filter caps were a bit how you're doing, but that was to be expected. So yeah, I think we will plonk in a new pair of caps and give it a general dusting and see if we can get rid of most of the... I haven't checked the diffusers are alive yet, and I haven't checked the power transformer and all that jazz, but I will get there. But I think this might be one that, just fires up almost instantly. There's very little wrong with it. I do have a schematic, bit bummed that it doesn't show, voltage ratings and wattages of different components, but, well, you just have to live with that, I guess. But otherwise, it's a nice, solid radio. The old circuit board is, a bit of a bummer. It would be a lot easier to do work on it if it wasn't, a circuit board. They packed it in quite well on this one. I'll get back to you guys once we're ready to fire this bad boy up, and we'll see what comes of it. Also have to figure out how the voltage selector is configured, but well, we can... okay. So it's set at 220 volts. That's good. There's the nameplate if you're interested in the exact model. This one must have gotten wet at some point. Like horribly wet. But we'll get it going. And as you can see, this, as I was talking about the stacking. It's an aggressive sort. Yeah, so that's the input for the gramophone. Where I might have another little trick up my sleeve where we might do some Bluetooth mod on this, because this one would be a nice, office speaker. I have to check where the 6.3 volt tap is, and maybe we can rustle up a regulated 5 volt supply from that and see where we are with that. I haven't really figured out how the buttons and everything on this works. There's one button that selects something, and this here with this mega switch that we need to clean. And there's this other one, which I'm not quite sure what it does. It might be the gramophone input, but I need to find it on the schematic and look it over. But yeah, that's all we have time for today. So thank you guys for watching, and hope you have a nice day.